Greetings and welcome to part one of Solar Domestic Hot Water Heating Systems, or Solar Thermal 101 through the MREA. This is our online course and my name is Benjamin Nusz. I'm going to be your instructor for the majority of these webinars and I'm really looking forward to it. Our first presentation here today is really about an overview of solar water heating systems. We're going to start really narrowing in on our course purpose and focus. And then we'll begin to talk about some of our solar water heating applications. We'll take a step back and actually look at the needs for being energy efficient and conservative of our usage. And then we'll look a little bit at the history of solar thermal and solar water heating systems throughout the United States, and also with a little bit of a global perspective. Now, the goal of this course, being that it's an introductory level course, is really to prepare you to have a basic understanding of how these systems work, how they function, what are the main components, but also to prepare you for more advanced solar water heating training. We want to help facilities managers, architects, planners, homeowners, or government officials to really understand how these things work. While it is an introductory level, you'll find that there's quite a bit of in-depth content that we're going to be going over. But a lot of it is, of course, kind of skimming the surface of a lot of these more in-depth topics. For instance, we're going to talk about where's the best place to site and place a solar water heating system. But that doesn't quite replace the full solar water heating site assessment course that will really tell you the ideal place to find that. So we will be covering solar domestic hot water system types, and of that we'll focus in on the collectors specifically. We'll look at solar storage techniques and then all of the other system components. How do we connect up these solar heating collectors to their solar storage tanks and really make them work? We'll spend some time talking about installation, maintenance, and siting and locating them, in addition to a little bit on system cost and economics. What we will not be covering are non-residential or large-scale commercial systems. We'll touch on some of the topics, and altogether placing and installing a commercial-based system is not that different than a residential one, but there's a few additional topics that we won't be covering here. We will not also be covering solar air heating systems. These are largely, the conversations that we're going to have are largely going to be on liquid-based systems, so solar water heating, not just solar space heating. Now, we can take liquid-based collectors and use them to heat buildings. We can also take air-based systems and use them to heat buildings, but we do not address it in this particular course. Most of that we focus on in our solar space heating course that is an advanced level. We will also not be addressing pool heating. Pool heating is one of the most common applications for solar heating in the United States, but this is really about solar domestic water heating systems. So we are going to be heating water that is used for things like showers and laundry and domestic purposes. Now, we first really want to talk about what we mean by solar water heating. When most people think solar, they think solar electricity. Well, we're not taking that solar radiation and turning it into electricity. We're taking that solar radiation in the form of heat and using it in the form of heat, primarily in the form of heat for water heating. So we're going to be collecting that energy and then using it to heat water that is normally heated by natural gas, propane, or electricity. So we are generally going to be heating things up somewhere between 120 to 150 degrees. Now that's our target. Most of the systems we're talking about, the common standard systems, can very easily on a single sunny day heat up a tank of water to 120 to 150 degrees. So applications that use heat at that range are our best choices or our most suitable systems for solar integration. Now, we can absolutely reach higher temperatures, and we do so regularly, but we don't collect the same quantity of heat that we do at these lower grade temperatures. And we're going to see how important it is to kind of maintain lower temperatures later on when we talk about collector performance. One of the things that we see is that the higher temperatures we're trying to reach, the less efficient our collectors become. Solar water heating collector efficiency is very dynamic. It depends on how cold it is outside, how hot the water is you're trying to heat. So we will not only be able to produce a higher quantity heat at these lower grades, but we make our collectors significantly more efficient. And we'll show you some of the graphs and figures later on in this particular course. So we want to find loads that are between the 120 and 150 degree range. So for domestic hot water, it's things like showers, laundry, dishwashing. Those are kind of our ideal choices. Typically, we're using domestic hot water in the 100 to 120 degree range when we think about showers and laundry and all that stuff, typically operating at those temps. Most buildings can easily be heated with around 120 to 150 degree range temperatures. There are certainly some high temperature hydronic heating systems that exceed that, but things like radiant floors or a water furnace and forced air applications are excellent choices that solar can do as well. And then, of course, pool heating, as we mentioned previously, we're typically going to be heating our pools up into the about 80 to 85 degree range. And so solar is an excellent choice there as well. Commercially, I know we're not going to be focusing too much about commercial systems, but commercial has a lot of solar thermal applications that we want to consider. So not just domestic hot water and space heating, but also things like makeup air heating. So commercial facilities are typically have a very high ventilation load. They're taking a lot of air and sending it outside and having to bring in fresh makeup air from the outside. And in the wintertime, that may be 0 degrees or negative 10 degrees. And so we'd like to be able to heat that back up. And solar thermal does an excellent job there. Also pool heating or process heating and crop drying. And we'll see some examples of this in the coming slides. But when we think commercial applications, our low-hanging fruit are really hotels, laundromats, pools, car washes, universities, and prisons. They are all excellent applications that we've seen a lot of solar water heating systems work successfully on. When we look at what a typical solar domestic water heating system looks on a residence, it's going to look something like this. We're normally looking at somewhere between 1 to 3 collectors to offset a typical household's usage. Now, it obviously depends on how many people live in that household and, of course, what size of collectors we have. There are some pretty standard sizes for collectors that are out there. Flat plate collectors typically come in a 4-foot by 8-foot size or 4-foot by 10-foot. Another common one is a 1 meter by 2 meter. So that's about a 3.5 by 7-foot style collector. The ones that you see on the screen here, those are 3 by 7s, and so there's 3 of them. Typically, a house will have somewhere around 60 to 80 total square feet of collector up on their roof. We've certainly seen some bigger ones on larger families, but it's going to look something about like this. Whenever we start to increase our loads and to do some space heating, of course, we add additional collectors. These particular collectors here are 4x8s that are on the front and 4x10s that are on the back. This is in a drain back configuration that's used for heating that building. This building happens to be, or this house happens to be in Iowa. Here's an example of a school, or as this is actually a university. This is UW-Milwaukee, and these collectors are used for dorms and cafeteria hot water usage. And obviously, as the loads increase, our collector sizes will increase as well, but you get an example of what they look like in some commercial applications. This is at UW-Stevens Point. These collectors are used for heating water in some of those dorms that are right there. Car washes are an excellent choice for solar water heating as well. This is in Bonduelle, Wisconsin, and car washes are actually an interesting example because they'll have a couple sources of hot water. One is kind of the water that's used in the actual washing, the soapy, the sudsy water that's there. But many car washes also have a reverse osmosis system, or a way to demineralize water. We integrated into a particular system that required the water be heated up to about 101 degrees, and then it was allowed to cool down again. But that was part of the demineralization, or RO, reverse osmosis process. And so it was a very low-grade load, an excellent choice for solar thermal. So we were heating up the reverse osmosis water in addition to heating up the water that got used in the actual washing process. Hotels are always an excellent choice for solar water heating because they have multiple different loads. You're going to have quite frequently a pool that's going to be in there. You're going to have all the showers that people are taking. Many of them have restaurants that include dishwashing. in addition, that many of them will do their own laundry. You've got sheets and towels and all this laundry that needs to be done. And all of those loads are, of course, in that about 120 to 140 degree range, and excellent choices for solar water heating. And who knows what else? Sometimes there's a very unusual types of systems. This one happens to be at a peaking electrical power plant that operates using diesel generators. So in our electrical grid, we have what we consider base load power, which is typically provided by coal plants. And that's always kind of providing some power out there. But if a bunch of people turn their lights on at once, they have a spike in power demand, and the coal plants are far too slow to be able to compensate for that directly. So we look to things like natural gas or diesel, things that can ramp up very quickly and can match the loads with their actual supply. Well, that typically happens when we have sunny days or everyone's turning on their air conditioning systems. And this particular system used solar thermal to keep the jackets that surrounded these diesel generators, to keep them warmed and primed. And so it was an interesting case there. Basically, we find out what those loads are, and then we find a way to offset them. This is an interesting system. This is was at Packerland Food Processing that was in Green Bay. I keep saying what was. This system covered almost 10 acres of land. It was in the Guinness Book of World Records as the largest solar water heating system at its time, 160,000 square feet of collection. Very, very big system. Unfortunately, because of a number of things, this system was decommissioned and disassembled. A few of these collectors ended up at the MREA. We had 16 of them, and we had them for about 15 years. Because of some changes on our facilities and on the fairgrounds, we had to take that system down and we put a new one up. However, those same collectors were then sold. Some of them we put up on a local CSA farm. Another set my students and I just put up this last spring, and they're working as almost as good as a brand new collector. So interesting system. Prisons, of course, always use a lot of hot water. Another excellent choice. So those are our typical places where we're going to see solar water heating systems. Obviously, that's not a comprehensive list, and we can go beyond that. But before we talk about solar water heating any further, I do want to take a step back and talk about efficiency. And one of the critiques that we hear about solar water heating, or solar in general, is that our systems are expensive. And we'll talk about economics later on, but it's not that our systems are necessarily so expensive. They end up costing a lot because our systems tend to be so large. They tend to be so big because we use so much energy to begin with. So one of the things that we want to do before we site, size, design, and install a solar water heating system is try to reduce our consumption as much as possible. By reducing our energy bills, we can reduce the size of our system and thereby reduce its cost. Also, energy efficiency has a tremendous amount of potential. Now, I actually break this efficiency into two categories, one of them being conservation. And conservation are easy things that can be done that reduce energy consumption that don't cost anything. When we're looking specifically at solar water heating, it's considering the ways that we use hot water and trying to reduce them. It may be things like just taking a little bit shorter showers. I always recommend to my students to take a timer in and actually time how long you are using your shower and whether that's actually going to be necessary. And it may be certain things that aren't actually compromising the way you do things, just shifting the way you do things, like making sure that you wash full loads of laundry or not start the dishwasher until it's a full load. And those sort of things, not only do they cost nothing, but they also then have an immediate payback. However, we can't conserve our way out of this mess. We will inevitably have to use some energy and use some hot water, but let's use it in the smartest way possible. And this is where I call energy efficiency, where we're looking at the equipment that we have that consumes hot water and upgrading that or making sure that it's the the most modern type of equipment. It may mean things like a front load washing machine or upgrading our water heater to a more efficient style of backup, or also looking at some of our faucets and fixtures, figuring out what usage they are and making sure that they are either WaterSense. WaterSense is an EPA guideline, WaterSense certified, or some other sort of low flow fixture. Oftentimes we can get low flow without sacrificing pressure. We're just reducing the orifice size, and so most of that doesn't actually mean a sacrifice in the experience that we have with some of those showers. If you have a particular like shower head that you're attached to, you don't actually have to always change out the shower head. You can put a flow restrictor in line that just reduces a little bit of the water flow that's leading up to it. And it may mean things like maintenance. Maintenance is oftentimes a part of energy efficiency. We think we just have to go out and buy something new. Well, like buy a new Prius or buy a new hybrid of some sort, when in fact we can just look at the vehicles that we already have, make sure that our oil gets changed regularly, our air filter gets changed regularly, that our tires have full of pressure. Those are maintenance things that can dramatically increase efficiency, that don't actually require us to make large purchases. And of course, insulating pipes is always critical. Now, I have a couple of favorite graphs, and this happens to be one of them. This is my favorite graph above all. And this one was put out by the American Solar Energy Society in 2007. And they put out a report called Tackling Climate Change in the U.S., Potential Carbon Emission Reductions from Energy Efficiency and Renewable Energy. You can see the link down at the bottom of the page here. And what they did is they looked at all of the current sources of renewable energy and looked at their potential, okay? And what they mean by is the potential for each of these technologies at a reasonable scale of deployment to offset carbon emissions. So we start here, and on the y-axis, you see U.S. carbon emissions, and this is in millions of tons of carbon a year. So a lot of carbon that's being released. But basically we see that this is where we're at. Other people look at this differently. Some will look at it in terms of parts per million, like 350.org and Bill McKibben, or they look at it in just the total tonnage or weight of the carbon that's going up into the atmosphere. Well, what we see here is that the further you go up, the more carbon. And what they did in this report is they said, well, okay, we need to figure out where we are, and that's where it starts, this 2005 level right there. And we need to figure out where we need to get. So they looked to the IPCC, the International Panel for Climate Change, or I don't quite remember exactly what the acronym is, but they put out the annual climate reports. And they said that in order to halt catastrophic damage caused by climate change, we need to reduce emissions somewhere between 60 to 80% of current levels by 2050. And so that's what these two dotted lines are. They say, here's where we are, here's where we need to get over here. This only goes to 2030, but here's where we need to get, and let's connect those 2 points. That's the path that we need to be on. However, what we see is that this line up here is typically referred to as business as usual. What would happen if we did nothing? Now, you notice that carbon emissions will continue to increase for a number of reasons. One, population will be increasing. So as populations expand, energy consumption and emissions will increase as well. But also we have the urbanization of large populations of people that are traditionally lived in rural, lower carbon emitting areas. People in China, people in India that are driving cars that never drove before, have moved to our city and have led to a higher carbon style lifestyle. And all of that, if we do nothing, will continue to increase. And that is the absolute wrong direction. So not only do we have to reduce from our current levels, we also have to account for growth. So what this report did is they said, okay, we know where we need to get to. How much can we reasonably expect from these technologies? Things like energy efficiency, wind, biofuels, biomass, solar electric, solar thermal, and geothermal technologies. And this is often referred to as the slices or the pies approach because the end result is all these look like little slices of pie. And so the first question was, should we even bother? Are the current technologies that we have sufficient to get us there? And the answer was yes. Yes, we should bother. And yes, we can get there using existing technology. And that's another key part of this. We always have this kind of mental dilemma. And I always ask my students this. If you had $1 billion, what's the better investment? Is it to take that $1 billion and invest in a Manhattan Project style of investment where you get a bunch of brains and you put them in the room and you say, solve our energy crisis, solve our carbon problems with a new technology, a more efficient solar panel, something along these lines? Or do you take that $1 billion and you invest it in a million PV panels that are out there right now? And most people tend to side in the latter camp, where our issue is not about the technology, it's a matter of deployment. So all of this supposes that there aren't major innovations and changes in the efficiency of the type of equipment. It's what we're putting up today. So at a reasonable level of deployment, reasonable level of penetration and capacity, we can get there. And so that's important for us. The other conclusions that we take from this is notice that there isn't a single technology that can do it all by itself. In other words, there is no silver bullet. Wind isn't the answer, solar isn't the answer. It's solar and wind. It's both of these technologies or all of these technologies that are put together. I refer to this not as a silver bullet, but as silver buckshot, right? We need to scatter this to all of these types of technologies. The other thing that is important from this graph is that the biggest slice of pie here is not solar, wind, or any of those. It is energy efficiency. It's about conserving the amount that we have. Energy efficiency is enough to basically curb growth. But note, it's not as sufficient to get us there. We need to be looking at efficiency and renewables. So both of them are going to be essential. And I like to start with this graph because it says, because if the conclusion was that solar and wind and renewables aren't going to get us there, then we should pretty much end this class as it is. But we know that that these are a critical piece in this puzzle, and both solar water heating, solar electric, and wind technologies are all critical in us getting to that particular point. When we look at solar water heating in particular, I like to start off by dispelling a couple myths. The first myth is that solar water heating is a new technology, when in fact the first solar water heating system was designed and invented and installed in 1891 by Clarence Kemp. And that's not a typo. Yes, that is 123 years ago. And this was a very simple technology. What you have is, this is the advertisement for that climax. And you had a series of steel tanks that were put inside of a box and a piece of glass put on over top of that box. They filled those tanks full of water, and lo and behold, they got hot. And you can see an example or the diagram of one of these here. And we have to remember what things were like in 1891. Not remember, but remember or imagine what they were like. We did not have gas or electric water heaters at that point. So if you wanted hot water, you had to light a fire, which was quite a pain. And so here we saw something that was automatic, instant hot water, and it was quite a luxury. The other myth is that solar water heating systems are rare, when in fact, there's been times where they have simply proliferated. We look at instances in, say, Miami, and there was a period where solar water heaters were the norms. 4 out of every 5 households had a solar water heating system. We'll take a look in one of our supplemental webinars about kind of the global picture, but what we see is that there's many places across the world where solar water heating has simply became the norm. I do like to look a little bit at this history about what happened between Clarence Kemp's climax in 1891 and today. And I like to break this down into three distinct sections, and they're really about three booms that have been going on. The first one was from the 1890s to about the 1950s, where solar water heating was a simple technology that was automatic hot water supply, that was a new innovation at that particular point, that didn't require you to start some wood or coal on fire in order to have a nice hot bath. However, in the World War II and in some of those areas, oftentimes, or in World War II, they froze a lot of the copper for non-military uses, and so that was part of it. We also saw electric and natural gas water heaters really take over the domestic water heating market. And so they were kind of replaced by something that was more consistent, that represented an even more modern convenience. However, by the 70s and early 80s, we realized that solar was once again a viable alternative because it didn't require the use of electric and natural gas. What we saw was the oil embargo, and we see here in 1973, the OPEC countries, the Organization of Petroleum Exporting Countries, refused to ship oil to the United States as a result of the U.S. to support the Israeli military during the Yom Kippur War. And what we saw is that in a very short period of time, and here we see 1973 and what happened, and in terms of the dollars price per oil, we saw that the price of oil basically quadrupled in a very short period of time. And the reaction was that we didn't need your oil. We have solar, and that's what we saw here. Is we saw solar thermal being one of these solutions. We saw do-it-yourself solar thermal in popular science and popular mechanics. Here's where we saw a lot of books being written about solar thermal. Here's where we saw a boom in manufacturing and installations. We saw all these new companies that were developing new solar water heating products, and we saw our market skyrocket. And solar thermal was viewed as patriotic. It was viewed as something that was very American to do. What happened, however, or part of what also spurned this was what was happening in the White House, what was happening in terms of the tax incentives that are out there. And so there were a lot of large tax incentives that encouraged people to invest in solar water heating systems. In some cases, the tax incentives were so large that we ended up with a kind of a mixed bag. There were a lot of excellent manufacturing companies and excellent installers out there, but of course there were some that were just chasing the tax breaks and chasing the tax incentives. So we got some really great installations. We also got some rather poor ones. There are many of the systems that were installed in 1970s and early 80s that are still functioning today. In fact, as I look outside of my house window, I can see a solar water heating system that was installed in 1976 that is performing today almost as good as the day that it was put in. So if they were decent or good quality collectors at the time, they can continue to last, and there are many of them that are at this point turning 40 and still performing well. However, what we saw, if we go to this graph, we were here, and then in the early 80s, the oil embargo ended. It ended for a number of reasons, but one of them was that because the oil prices were so high, we invested heavily in exploration. We explored the North Sea, we did offshore drilling, and we found or were able to extract oil in all these places that previously it was cost prohibitive. And then the oil embargo ended, and now the world had a glut of oil. And that's what we saw. We saw oil and energy prices plummet in a short period of time and then relatively stabilize. We've seen them go up, and now we're kind of in this trajectory where it's kind of like bumpy peak. When those incentives ended, we also saw the market plummet as well. And as a result, solar in the US kind of all but halted. There was more of a bottleneck than a complete abrupt shift. What we did see is that globally, there are a few places that carried on. So for instance, in 1974, the country of Israel put in a solar mandate. And what that means is that every house is required to have a solar water heating system. It's basically written into their code, just as our code says you have to have, your 2x4s placed 16-inch on center for interior walls and so on. That their code says you must have a solar water heating system. And so in places like that, it simply is the norm. There are places like that in the United States that are now doing that as a result of what we see, this kind of third solar boom. So in the 2000s, and the mid 2000s through today, we see a different motivation for this. Some of it is just diminishing resources and global climate change and rising fuel prices, concern about the environment, and people that are more interested in green and local jobs and funding it for that reason. So we are seeing a global increase that has really started about 10 years ago and is greatly increasing the amount of solar that is out there right now. I do like to always talk about the White House as an example of what's happening with, or what happened with the solar water heating industry, because it is really emblematic of national opinions and policies and practices at that particular time. In the Carter administration, he was a big advocate of practicing what you preach, and was known to turn the thermostat down in the White House, and he referred to this kind of energy crisis as the moral equivalent of war. And as a result, he, after a press release and a big press conference, installed a solar water heating system on the west wing of the White House. And that system, you can see right here, this one here is on the west wing, which is basically where the offices and administration part of the White House is. And that was up for several years, but then Reagan took it down. Now the official line on that is that the roof underneath it needed some maintenance, and so instead of putting them back up, they basically took them down. Where those particular collectors stood in or remained in a warehouse for a number of years, where they were eventually recovered and put up at a school somewhere in the Northeast. There's a movie about the kind of path and history of those particular collectors called The Road Not Taken, which is part of Jimmy Carter's speech. When he gave the press conference, he said, and I'm paraphrasing here, that these collectors and this system can be a symbol of our new energy future and the way that America can go, or this can be a road not taken. And eventually, oddly enough, the system was taken down, and it did represent the road not taken, because at that point, Reagan eventually took down that system, and America largely followed suit. One of the people that I learned this industry from is my father-in-law, Bob Ramlow, the co-author of the book with me. And he's one of the people that was involved in this solar water heating industry really from the start, and was a solar installer for many years. And when all these other companies went out of business, he stuck around and fixed and retained all these systems and maintained them, and gained a lot of knowledge about what works in the long haul. And what we saw was that many of these systems were being taken down just because of roofing issues, or because just a lack of maintenance, or the homes changed hands. And just like the White House, a new homeowner comes in, they're not sure how it works, they don't see the value in it, so they just say, take it down. And so for a number of years, the best place to find still good but used collectors was from roofers. They would go and they would want to have to redo the roof, and instead of taking them down and putting them back up, they just took them down and left them down. Then we saw the White House change hands a couple of times again, and Clinton, historically, and of course his vice president Al Gore, were large proponents of solar, and they managed to put a solar water heating system on the swimming pool in the courtyard. And really, that's where we saw the majority of solar water heating in the 90s, is that we had a very strong and very robust solar outdoor seasonal pool heating industry. And so that's what we kind of saw the Clintons do. Most people don't know, but during the Bush administration, a solar water heating system and a PV system were installed on the White House. They weren't on the White House proper, they were on one of the grounds buildings. And the latest update is that President Obama installed a PV system this year. The big press conference was in 2010, but the system just got installed this year. So we see here, this is where solar was. This is in 2007. The number has increased a little bit. And we see that solar really only represents about 1%. Now it's about 1% of 10% of the total amount of energy we use. And I actually like to look at it in terms of this graph. Now, this one is a little out of date. This is the 2006 one. The paths are largely the same. It's just the quantities are different. But I keep this one in the PowerPoint because it's out of 100 quads of energy, and so it allows us to kind of look at this in terms of percentages. And this one needs a little bit of explanation. So what we see over here is we see all of the sources of energy, and then if you follow the path, it kind of tells us where it goes. So we start off with solar and nuclear and hydro and wind, geothermal, natural gas, coal, biomass, and petroleum. And then we see what path they end up being used on. So we see 22% of all the energy we consume is coal, and most of it gets used towards electrical generation. And 40% of all the energy we consume is petroleum, and most of it gets used for transportation, some industrial. Then we see some like fuel oil that gets used for residential heating. So it's always interesting to look at where we start with all this energy, but also where it goes. And the most interesting thing is what actually happens on the end here. We see that out of those 100 units, 57 of them, or around 50%, get wasted. And this is why energy efficiency and conservation can have such a great impact, because these things have to grow, but it's actually a lot easier to try to shrink these numbers over here, to try to shrink how much we're wasting. This one is always kind of shocking to me. What we see in terms of solar thermal and our collector shipments is that they continue to increase. We had kind of a spike in 2006, and then there's a slight lull after that, and our numbers are continuing to increase again. Most of those are going to be in the medium temperature or low temperature range. This is the number of companies that existed in the United States in 2009. In the medium and low temperature companies, there's about 26 different companies that are out there that are making products. We contrast that to what we had in the early 80s, where we had over 100 different companies that were making solar thermal collectors. When we look at this globally, and we'll talk more about this later, we see that China, in terms of capacity, is clearly the world leader. They install about 80% of all of the solar collector area in the world, and very, very large capacity. However, when we look at it in a couple of other methods, this one we see, this is the total capacity. We see China is leading. People are always surprised that Turkey is the second. And then we see, of course, Germany, and we see the United States over here. Now, China leads in capacity, where they're putting in about 20 million solar water heaters a year, but they don't lead in terms of per capita. Places like Cyprus, Israel, Austria, Greece, those areas, there's basically solar for everyone. Every house has solar water heating systems. So we see in this particular case, China drops down in terms of per capita. So to sum up this section, we looked at the kind of history of solar water heating. We looked at its justification, and then we looked at a little bit in terms of its global perspective, that there's some other countries that are installing a much greater capacity than us, but that just means that we have a greater potential for growth. Here's other works cited that are out there, and we will talk to you again soon. Thank you.